Hello, curious minds. Welcome to the Healthwise show. Today, we're diving deep into the fascinating world of laboratory glassware. We'll be exploring the different types of glass used in laboratories and why choosing the right type is crucial for your experiments. From withstanding scorching temperatures to handling corrosive chemicals, each type of glass has unique properties that make it suitable for specific tasks. So buckle up and get ready to unlock the secrets of these essential laboratory companions. When it comes to experiments involving high temperatures and sterilization, high thermal resistant glass is our champion. This type of glass, often made from borosilicate, is like the superhero of the lab, capable of withstanding extreme temperature changes without cracking under pressure. Imagine heating a liquid in a regular glass beaker. It might expand rapidly and shatter, creating a mess and potentially a safety hazard. But fear not, high thermal resistant glass is here to save the day. Its low coefficient of thermal expansion allows it to withstand rapid temperature changes, making it ideal for heating, cooling, and sterilization processes. Remember those iconic Pyrex dishes used in kitchens worldwide? They're made from borosilicate glass. In the lab, Pyrex beakers and flasks are staples, known for their exceptional durability and resistance to thermal shock. But wait, there's an even tougher contender in the high thermal resistant glass family, Corex. Developed by Corning, the same geniuses behind Pyrex, Corex takes durability to a whole new level. It's chemically strengthened, making it incredibly resistant to breakage from impact, scratching, and even the harshest laboratory conditions. So, whether you're dealing with extreme temperatures or need glassware that can withstand the test of time, high thermal resistant glass, especially Pyrex and Corex, are your go-to solutions. Now, let's dive into some specific applications where high thermal resistant glass shines. Picture a microbiology lab where sterilization is crucial. High thermal resistant glass containers like Erlenmeyer flasks and Petri dishes can be safely autoclaved at high temperatures to eliminate any unwanted microorganisms. This ensures a sterile environment for experiments and prevents contamination. In chemistry labs, high thermal resistant glass is used for a wide range of applications, from heating reagents to conducting reactions at elevated temperatures. Its ability to withstand rapid temperature changes makes it ideal for processes like distillation, where liquids are heated to their boiling point and then condensed back into a liquid form. And let's not forget about research labs, where scientists are constantly pushing the boundaries of knowledge. High thermal resistant glass plays a vital role in experiments involving high-intensity lasers, plasma torches, and other advanced technologies that generate extreme temperatures. Its exceptional thermal properties make it an indispensable tool for scientists exploring the unknown. So remember, when the heat is on in the lab, high thermal resistant glass is our trusty sidekick, ensuring accurate results and a safe working environment. In the realm of analytical chemistry, where precision reigns supreme, high silica glass takes center stage. This remarkable type of glass boasts an incredibly high content, typically over 95%, giving it exceptional purity and chemical resistance. Imagine a world where even the tiniest impurities could skew your experimental results. That's where silica glass comes in, ensuring safety and reliability in every measurement. One of the properties that make high silica in analytical labs is its low coefficient of thermal expansion. This means that it barely expands or contracts when exposed to temperature changes, ensuring precise volume measurements, even when working with volatile substances. Think of it as the unwavering ruler of the lab, always providing no matter the conditions. It's not all. High silica glass also exhibits exceptional chemical resistance, making it impervious to most acids, alkalis, and organic solvents. This remarkable inertness, perfect material for creating, which are used to heat substances to extremely high temperature and volumetric flasks, solutions with precise concentrations. Moreover, high silica glass is highly transparent to ultraviolet and visible light, a crucial property in spectrophotometry used to measure absorbance and
through a solution. By using cuvettes made from high silica glass, scientists can accurately measure the concentration of substances in a solution with the interface from the container itself. Its exceptional properties, high silica glass is also incredibly durable and long-lasting. It can withstand repeated heating and cooling cycles without losing its structural integrity, making it a cost-effective choice for labs that demand both precision and longevity. So whether you're analyzing trace pollutants in environmental samples, developing new pharmaceuticals, conducting edge research, high silica unsung hero of the analytical lab, ensuring accurate results and driving scientific advancements.
Hold on to your goggles because we're about to enter the world of high alkali resistant glass, specially designed to handle the most caustic substances in the lab. As the name suggests, this type of glass is highly resistant to attack from strong alkalis, like sodium hydroxide and potassium hydroxide, which can eat away at other types of glass like a monster munching on a cookie. One of the key features that make high alkali resistant glass so resilient is its unique composition. It typically contains a high percentage of zirconia or alumina, which impart exceptional chemical resistance, particularly to strong alkalis. Think of it as a suit of armor, protecting the glass from the corrosive wrath of these powerful chemicals. However, even superheroes have their limits. High alkali resistant glass is not invincible and requires careful handling, especially when it comes to temperature. Unlike its high thermal resistant cousins, high alkali resistant glass is more susceptible to thermal shock and can crack if heated or cooled too rapidly. So, when working with high alkali resistant glass, it's crucial to avoid sudden temperature changes and to use gentle heating and cooling methods. For instance, instead of placing a hot beaker directly on a cold surface, use a wire gauze or a hot plate to gradually cool it down. Despite its sensitivity to temperature, high alkali resistant glass plays a vital role in various laboratory applications. It's commonly used in analytical chemistry for titrations involving strong bases, in organic synthesis for reactions involving strong alkali reagents, and in the manufacturing of certain types of batteries. In analytical chemistry, high alkali resistant glass burettes are used to precisely deliver measured volumes of strong base solutions during titrations. These burettes are carefully calibrated to ensure accurate measurements, even when working with highly corrosive solutions. In organic synthesis, high alkali resistant glass flasks and condensers are employed in reactions that require strong bases, such as the synthesis of soaps, detergents, and polymers. The chemical inertness of this type of glass prevents it from reacting with the reagents, ensuring the purity of the final product. Furthermore, high alkali resistant glass is used in the manufacturing of certain types of batteries, such as nickel-cadmium and nickel-metal hydride batteries. The electrolyte solutions in these batteries are highly alkaline, and high alkali resistant glass separators are used to prevent short circuits between the positive and negative electrodes. So, while high alkali resistant glass may not be as versatile as other types of glass, it's an indispensable tool for scientists and engineers working with strong alkalis, enabling them to safely and effectively conduct experiments and develop new technologies. Step into the world of low-acting glass, where sensitivity to light is a priority. This unique type of glass is specially designed to protect light-sensitive substances from degradation or alteration caused by exposure to ultraviolet, UV, and visible light. Think of it as sunglasses for your chemicals, shielding them from the harmful rays of light. But what exactly makes low-acting glass so special? It all comes down to its composition. This type of glass is typically amber or red in color due to the addition of metal oxides, such as iron oxide or manganese oxide, during the manufacturing process. These metal oxides act as light absorbers, effectively filtering out harmful UV and visible light wavelengths. Now, you might be wondering, why is it so important to protect certain substances from light? Well, many chemicals, particularly those used in pharmaceuticals, photography, and certain areas of research, are highly sensitive to light. Exposure to light can cause them to degrade, change color, or even lose their effectiveness. Imagine a scenario where a light-sensitive medication is stored in a clear glass container. The constant exposure to light could break down the active ingredients, rendering the medication ineffective or even harmful. This is where low-acting glass comes to the rescue. By storing light-sensitive substances in containers made from low-acting glass, we can significantly extend their shelf life and preserve their potency. The amber or red hue of the glass acts as a barrier, preventing harmful light from penetrating and causing unwanted reactions. Low-acting glass is particularly crucial in the pharmaceutical industry, where many medications are stored in amber-colored glass vials to protect them from light degradation. This ensures that patients receive the full therapeutic benefit of their medications and minimizes the risk of adverse effects. In photography, low-acting glass is used to store light-sensitive chemicals, such as developers and fixers, which are essential for developing and printing photographs. The amber glass bottles protect these chemicals from premature degradation, ensuring consistent and high-quality results. Moreover, low-acting glass is also used in certain areas of research, such as photochemistry, where scientists study the interactions between light and matter. By using low-acting glass to control light exposure, researchers can precisely manipulate chemical reactions and study light-induced processes. So, the next time you encounter an amber-colored glass container, remember that it's not just for aesthetics. It's a testament to the importance of protecting sensitive substances from the invisible forces of light, ensuring their stability, efficacy, and safety. Let's talk about the unsung hero of the lab, the workhorse that's always there to lend a helping hand, standard flint glass, also known as soda lime glass. This type of glass is what we typically encounter in our daily lives, from windows and bottles to drinking glasses and jars. And yes, it also plays a significant role in the laboratory setting. What makes standard flint glass so ubiquitous is its affordability and ease of manufacturing. It's composed primarily of silica, soda ash, and limestone, readily available and cost-effective materials. This makes it the go-to choice for applications where high temperature resistance or chemical inertness isn't a primary concern. In the lab, standard flint glass is commonly used for making test tubes, beakers, and other general-purpose glassware. It's perfectly suitable for tasks that don't involve extreme temperatures or highly corrosive substances. However, it's important to note that standard flint glass has its limitations. It has a relatively high coefficient of thermal expansion, making it prone to breakage when subjected to rapid temperature changes. So, while it's fine for gently heating or cooling solutions, it's not the best choice for applications involving high heat or extreme cold. Moreover, standard flint glass is more susceptible to chemical attack compared to its more specialized counterparts. Strong acids, alkalis, and certain organic solvents can corrode or etch the surface of the glass, potentially contaminating experiments or compromising the integrity of the glassware. Therefore, it's crucial to be mindful of the limitations of standard flint glass when using it in the lab. Avoid using it for applications involving extreme temperatures, strong chemicals, or long-term storage of sensitive substances. Despite its limitations, standard flint glass remains an essential part of the laboratory landscape. Its affordability and versatility make it a practical choice for a wide range of everyday tasks, from mixing solutions to conducting simple experiments. So, next time you pick up a standard flint glass beaker, take a moment to appreciate its simplicity and its contribution to scientific exploration, even if it's not the flashiest tool in the shed. From the heat-resistant champions to the light-sensitive protectors, we've journeyed through the diverse world of laboratory glassware. Remember, selecting the right type of glass is paramount for successful and safe experiments. Always consider the specific requirements of your experiment, such as temperature, chemical compatibility, and light sensitivity, to choose the best glassware for the job. And don't forget to consult those trusty material safety data sheets and lab guidelines for detailed information and safety precautions. Stay curious and safe. Until next time.